There's a meerkat.
He
Yes.
was waiting for you in Denmark, but you never came.
I'll come. I'll come. I promise. As soon as I come, as I can.
I have a song for you guys as well. I don't know if is this going live? Oh my God, we're live.
Yeah, I can hear you.
So the song says like it goes kind of angular by day, angular by night. Learning how to code makes your future bright. Come sink it with me. Angular is the key. If it's a pattern, come sink it with me. Hey,
Nice.
how's it going?
We should get like little captions and do karaoke or something.
Yes, I mean, it sounds like it's going to be an amazing event. We have the, I see your beautiful home in the background. I like the setup, amazing beard. And we have you, we have Lars, and we have Nishu. So I think it's going to be an excellent event.
Should definitely be fun. Oh, yeah.
And we're going live. This is amazing. Darek, are we starting this show? I think everyone is super excited.
Now officially we can start.
So, so I wasn't.
Yeah, you was live, but now we can start. So do it again, please. It was beautiful.
I thought I was going live, sitting in Hawaii, having a good time. So I composed this song from various sources, and I want to sing it to you guys. So once again, angular by day, angular by night, learning how to code makes your future bright. Whoa, whoa. So that's all, guys. You know, it's starting with this beautiful, you know, Hawaiian accent. Aloha, guys. We're about to have an amazing event with amazing teachers. So hopefully we brought some sun into your homes, into your environments where you're seeing this. And you know, without further ado, we're having Sebastian going first, and then there's Nishu, and then Lars. So enjoy, learn, you know, and make your future bright.
Nice.
Thank you so much, Ski. Thank you so much. So Sebastian, the stage is yours. Bam.
Perfect. So I cannot promise that I will sing, and because we don't want to kill your eardrums, but I would definitely like to present my screen. So let me know. Oh, I need to allow Zoom to actually share. I need to drop out from Zoom and come back in a second. Sorry.
So while we wait, some ukulele going on. I don't know what you guys doing. I wish I could talk to all of you right now, but you know, this is not a TCP connection, it's just UDP, so it goes just one way. I can make sure you hear me. I just can hope that, you know, I'm putting out the message and you're receiving all the packets coming from this wonderful Hawaiian place.
And Sebastian is
And I'm back. Sorry, I just didn't realize that I didn't use Zoom on this specific Mac, and you need to give permissions to any application that's trying to do screen sharing. So yeah, that's basically me. So I should be able to share my screen, and you should be able to see my presentation. Can you see that? Perfect. Okay, so I am not very used to actually sitting down and presenting. So if I wander off the screen at some point, do not be alarmed. That just basically means that I'm getting too excited about what I'm presenting, and I just need to get a bit of exercise. So what I want to talk to you about today is building chatbots. But first, I want to give you a tiny introduction to who I am. So basically, my name is Sebastian Witalec, in case you are wondering how to pronounce it. I'm a senior developer advocate at Progress. And if you're on Twitter, you can follow me at Sebawita. And some days I tweet a lot, some days I'm pretty quiet. So definitely you should check it out. And one personal thing that you should all know about it, and I don't think I say it enough, I'm a big fan of meerkats. Like any type of meerkats, like they're adorable, they're sweet. And one day, and this is not a joke, I have a plan to actually have my own meerkat enclosure, right? Like I'm planning to have like a specially built enclosure with a whole family of meerkats. And I just want to watch them because they're so amazing and so cool. And I do not expect to pet them because as cute as they are, they can bite your fingers off. So be careful with dealing with meerkats. I may have had or not this kind of experience with a meerkat before. So what is the agenda for today? So I want to tell you a little bit. We're going to start with some fun. So I'll tell you what chatbots eat, whether chatbots have dreams. I'll actually say why I think we should use chatbots and why we need them. And I'll go over some of the usual chatbot challenges that I saw with some other chatbot engines. And I'll actually build a chatbot in front of you on the screen, which is pretty cool. So first things first, and I know I can't hear all of you on the other side of the screens, but I do want you to shout the answers to those questions, and I'll telepathically try to get the answers from you. So first questions like, what do chatbots eat? So I want to hear telepathically, yes, some of you getting the right answers, and the answer is they eat pizza. Like chatbots are built by developers, and basically, well, they also teach their little babies, little chatbots, that they should be eating pizza. Next question, do chatbots have dreams? And I hear some good answers, some bad answers. So if they dream, what do they dream about? Well, they all dream about electric sheep. So if you, I'm a big fan of Blade Runner. So if you watch Blade Runner, you understand this reference. So finally, to slightly more serious question, like why chatbots? Like why should we even bother? The whole idea is, and the way I see is like the communication nowadays has completely changed. And I don't even mean the crisis that we're going through, but including that, is basically we used to be more of creatures that we would talk to each other, right? Like while we change from picking a phone or going and visiting friends to more of a texting relationship, right? So it is very popular that we'll be using either Viber or WhatsApp or all kind of messengers to communicate. And I've been in situations where I would be sitting at the dinner with a bunch of friends, and the person that would sit next to me or be like, a bit across the table would literally send me a text message during a dinner where we could actually exchange, because for some reason we find it more comfortable and easier. Plus, I believe that text messages in themselves, they're a lot less intrusive, right? So when you talk to somebody, you demand immediate attention, while when you send somebody a text message, then they can respond to you or read that message when they're free and ready to do so. So if our interactions with each other has changed, so should the companies and businesses, and the way we communicate with our customers should also change, and we should provide them with this additional channel of communication. So chatbots have a bunch of interesting benefits, and there's a ton of them, but I'm going to list some of my favorite ones. So in general, chatbots can improve your customer service. Like there's no doubt about it, especially if they're well made. They can reduce the common reception or / call center pain points. So chatbots are pretty good with dealing with repetitive tasks and questions coming from the users, so that actually people who work in those call centers can focus on things that are more challenging and require actually human input. Chatbots can work 24/7, so you don't have to worry about like people or some of the customers that I don't know, like to ping you at 3 a.m. or those that are in completely different time zone. Like chatbots are always available, and they're happy to respond to any questions. Like mentioned before, they're great at handling repetitive tasks, and they do not get bored, right? So if you ask the same question over and over to a friend of yours, they're gonna get tired after a while. But if you ask chatbot the same question 20 times, they'll just give you the answer 20 times, which is pretty cool. They're very, very patient with their users. And the speed of communication with chatbots can also improve, and that's mainly because they have direct access to the data, right? So if you connect your chatbot with your backends, with your CRMs or what sort of systems that you are using, then the chatbot can very quickly get the answer to any type of question that you are configuring it to, which is pretty great. But most importantly, really, why I think we should all be building chatbots, because it is fun to build one. So I personally enjoy building chatbots, and I have all sort of crazy ideas. Maybe some of my chatbots involve pygmy goats, maybe they involve meerkats, or maybe they involve pizza. You never know. So let's move on. So what are the usual chatbot challenges that we can experience from time to time? So some of the chatbots I saw, they'll have fixed decision trees. So what I mean is that the chatbot will expect you to provide the input in one specific order and also in a very specific format, which is not always great. So you could start with a chatbot that says, I want to book a flight to London. And for some reason, the screen, my mouse disappeared. Trying to hide the faces because I can't see my own presentation. Nope, can't do. Anyway, so you could have a chatbot that basically you tell it that you want to book flight, a trip to London for Wednesday, and the chatbot can respond with like, hey, yeah, I can help you with that. Where do you want to go? And this already means that the chatbot didn't quite catch the fact that you already provided with some of the information, because the chatbot kind of works in steps of, hey, first I'm going to identify what this conversation is going to be about, and then I will ask the questions for when I'm ready. So then the chatbot can follow up where you could provide your answer, then the chatbot says when, and then you say on Wednesday, and the chatbot can also say like, well, I didn't get that because they're fixed in terms of understanding the input, and they specifically want you to provide a date. And then the chatbot can kind of carry on and ask for how many people. So I'm just gonna zoom out from this slide for a second and hide the faces so that I can see the slides, and I'll come back. All right, we covered this. There you go. The next thing that I saw in terms of challenges of chatbots is like some chatbots wouldn't necessarily understand business entities. So what I mean by that is like if you're building a chatbot for a zoo and you saying things like, where are the meerkats, or where are the elephants, you know, where can I see the elephants? Well, we asked about that, but what do lions eat? The chatbot, if you don't train it, they wouldn't understand those entities like the animal names that you're interested in. And that can lead to very awkward conversations. So I have one that is based on a doctor's clinic, and you have a conversation when somebody comes up and says, hey, I want to meet with Dr. Burke on Tuesday. The chatbot responds, I can help you book an appointment. What is your doctor's name? And this is already where the problems start happening, because you said it's Dr. Burke. So you're confused and says, what? And the chatbot says, what time would you like to see Dr. What? And then the user says, what is going on? I'm not sure I understand you. Me neither. And this is only because the chatbot wasn't able to understand the entity of a doctor that is part of the clinic that this chatbot is for. So we could easily fix that by training the chatbot to understand. So when you say something like, I want to meet with Dr. Burke, the natural language processing should be able to also identify Dr. Berg as one of the entities and then provide some additional information about this doctor. And then automatically, then the chatbot can include the doctor's name in a conversation and say, what time would you want to meet Dr. John Berg on Tuesday? And then everybody's happy. Another one is around lack of proper acknowledgements. So that's something that it might not be immediately obvious, but sometimes you might be providing a lot of information when you're trying to, let's say, book some kind of service. So here's one where you say, I would like to sign up for a health insurance for a surfing trip to Szyszczyzewoczyce. I did that to myself, for my name, May the 9th to May the 14th. And the thing is that right here, we are providing the chatbot with 4 different types of information. We're telling that it's a surfing trip. We're giving it a city. We're giving it a date from and date to. So that technically the chatbot should be able to catch each of those entities and then understand. So if the chatbot responds with something like, what is your age? We are not quite sure whether the chatbot got the information that we are providing, right? So this can be a little bit daunting. So a better way of doing that is basically when I say that I want to do a surfing trip in Szyszczyzewoczyce, I want the chatbot to acknowledge that. So I wanted to say a surfing trip to Szyszczyzewoczyce is always a good idea. Add a little bit surfer and then confirm the date. So saying like, let's find you an insurance from this date to this date. And at this point, when the chatbot asks you, what is your age? You as a user feel very comfortable that the chatbot understands what is going on and everybody's happy. Another one is dealing with ambiguities or the lack of it. So English, in my opinion, is a very ambiguous language by default. And Polish is somewhat like a little bit more specific, but like I found that English can be very easily misunderstood. So if you have, and this is not partly ambiguous sentence, but if you have something where you provide 2 types of entities, like I talked to Dr. Berg and he told me to book an appointment with Dr. Alcott. So what could potentially happen is that the chatbot could think that you really mean Dr. Berg that you want to have an appointment with. So you would go and say, sure, when would you like to see Dr. John Berg? And then the user can go like, no, I actually want to see another doctor. What is going on? So the good way of dealing with this kind of situation is we could train the chatbot or instruct it so that whenever it sees like multiple instances of the same type, so multiple doctors in a sentence, it could actually ask the user to specify. So you could say like, hey, can you clarify which doctor do you want to see? And then provide little buttons so that the user can pick one of them and then the conversation can progress happily. Another thing is not using the long-term memory. So it's basically, if you keep coming back to the same conversation or coming back to the same chatbot, let's say once a week or every day or on a regular basis, it would be good for the chatbot to remember some of those details, right? So if you start with a sentence like, hi, it's me again, can you book me an appointment with Dr. Berg on Tuesday at 11? You would hope that the chatbot would kind of remember some of the information from the previous session. So the chatbot gives you an acknowledgement. Sure, let me help you book that. What is your phone number? And then at this point, if I've been doing that every week, like every Monday for the past 3 months, you would hope that the chatbot would already remember the phone number. So that's kind of like, can be kind of annoying. So obviously, we should definitely be using long-term memory. So if somebody comes up and says, I want to book an appointment, you give it an acknowledgement, and then you could actually just ask to verify the phone number. So you could say, hey, is this still your phone number? And at this point, the user can say yes, and we can proceed, or they can say no, and they can provide us with a new number, and that's a lot better. So based on some of the things I showed you already, building chatbots should be pretty easy, right? Well, it can be kind of tricky, and that's a little bit of a motivation as to why we created our own chatbot engine. So a few years back, at Progress, we had like a local hackathon that was done in Sofia, and many teams joined. And one of the teams wanted to build a little chatbot that would be like a virtual assistant that would help us book meeting rooms. And the idea was pretty simple. You come to the chatbot and say that you want to book a meeting room for how many people, whether you need some like audio video equipment like cameras or some other things. And then you may provide some additional information in that conversation. And that sounded pretty straightforward, right? So we're all kind of like hyped up, ready to go, and it was like, yes, this is a very good challenge. We should be able to build that in a couple of days. So then we started creating like this logical tree in terms of understanding how the whole flow would go of the chatbot. And this is not a joke. This is an actual picture of the version 1 of the logical flow for that chatbot. And we immediately knew that there was no way we could implement that by using just classical if-else kind of statements, because that just wouldn't work, right? And without any surprise, our process of the 2 days of building chatbots sort of went like this. Well, at first we were like, this is not gonna work. This is gonna go crazy. And at the end, we delivered pretty much about 10 to 20% of the features that we're planning to, and it would have taken us way much longer to do like just this scenario if we wanted to use like a classical style of programming. It just was not a way to be. So based on that experience, we kind of thought, well, it is not about the failures that you go through, but about the lessons that you learn from them. And what we learned basically was that there should be a better way of doing that, and there should be we should be more focused about declaring what is it that we're building, as opposed to coding every tiniest bit of this kind of conversations. So we came up with this, what we call nowadays native chat, which is an AI-powered platform for creating intelligent chatbots. And the main point is, and this is pretty much the most important part of a description of native chat, we're using a declarative programming language. So there's no if-else statements. What we do instead is we tell chatbot that if there's a conversation, we tell it what sort of information we need to get from the user in order to complete this conversation. So we declare the intent, and then the chatbot takes care of the flow and the presentation of the whole conversation to the user, which is pretty great. So we use JSON for describing conversation, and I'll give you an example. So if each conversation step would be of certain type, so maybe you want to ask a question. So the next thing we would say is what type of information we're trying to get from the user. So we could train the chatbot that we have an entity type country, and we accept values like France, Germany, Italy, or Poland. And also like the entity itself is like a name of a variable. The next step is we provide a little prompt. So this is the question that the chatbot will ask to the user in order to get the country. So we ask, which country are you traveling to? And the final thing is we can use different UI helpers. So in this case, I can say, display all the available options as quick reply, which in our language basically means create a little button for each available country from our training. And just this little bit of code can create a conversation that looks just like this. So you can say, I want to order a car, and the chatbot gives you which country you're traveling to, and we have the list of buttons, and we're able to choose Italy, and then the chatbot can move on to the next step. It's pretty neat. Like, it required very little code, and we already had this whole interaction based on that. And the other really cool thing is that with just one definition of the chatbot, we can then deploy it to Alexa. So we could actually use voice commands to do that. You could use Facebook Messenger, Viber. We could deploy it to any web application or mobile application. And we are currently working, and that's coming really, really soon, with integrations for text messaging. So you could have a very let's say simplified in terms of user interface, but you could send text messages and you could text with a chatbot and we would respond with all sort of information that you might need. And also we are working on WhatsApp integration, which is really, really cool. And we already have it in a working state, but we're going to release it to behind a pilot. So if you are up for testing it out, give me a shout and I can connect you up with the right people. So it's time for a demo and build a little chatbot that can help us basically serve a pizza. Okay. So what you see in front is one of my sample projects, which has like all bunch of different conversations already pre-configured. But I'm going to create a new conversation, which is basically the idea is that I want to order a pizza. So I would train this chatbot to allow somebody to order a pizza. So the first step that I have to do is just create a new conversation. So we have a little helpers in terms of, in the image of code snippets. So I'm going to choose conversation goal, and this is going to be pizza. Well, actually, no, let's call it order pizza. So that's the name of the conversation. Let's add a comma. And this already creates a structure for our chatbot. So our chatbot will have a bunch of steps in here. And the first step I want to do, just to do like a little hello world, I'll create a step of type message. And I'll say hello world. And since this is pizza themed, I am going to, let's search for pizza. Yeah, hello world pizza. Cool, let's save that. And the next thing that I have to do is basically train to chatbot when to trigger this conversation. So I can go into training and we have conversation triggers. And I already have like various triggers for other conversations, but for order pizza, I can actually say when somebody says order pizza, or I am hungry, or give me pizza, then that means that we want to trigger this conversation. So now if I say order pizza, the chatbot responds with hello world, right? Or I can say I am hungry, and the chatbot again responds with the same message. Okay, that's not super impressive just yet. So let's build a conversation that is more impressive, and we'll probably have to go through few steps. So first step should be pretty much, we should be able to ask the chatbot for, let's say, the size of a pizza and maybe what pizza they even want, right? So I can do step of type question, and we'll ask the user for what size of the pizza they want. And I will say that the entity type should be size, which we'll create in a moment. And I can ask something like, what size of the pizza would you like? And this basically should create, display the question to the user. And if I say display type quick reply, it would display a list of available options to the user. So for now, if I just say order pizza, oh, actually, yeah, it already gives us the pizzas. So we have large, medium, and small. And those entities basically get created inside here. So I'll show you how to actually create each of those. So for the size itself, we add an entity, I say its size, and it could be a keyword based. It could be based on traits, so it's like types of expressions, or we could use regular expressions. So regular expression is pretty good for like registration plates, for example, and things like that. And then we could either train based on static data or dynamic. So static is where we enter things manually. Dynamic, we could use web services to load the data. So I'm going to create a static list. So I can say we'll have large, and the synonym, for example, could be if somebody says 15-inch. So either this or this will trigger it as large. Then we could say medium, and that will be 12-inch. So 12, okay. And then the final one, I can add small, and that's going to be really tiny pizza, meerkat size. which is 9 inches. And that basically would give us that list of entities. And the other thing that we should probably create is another training that our chatbot should know about available pizzas. So I have this API that if I go to demo API /sample/pizza, it will give me a list of available pizzas, and each will have name, price, image, and type. So I will set it as my endpoint. And the value type is basically which of the properties do we want to use for training. So obviously I could train it on pretty much anything that is available here. So I could say, hey, recognize a record when somebody says meat, right? Or says specific price. So obviously these are very simple example, but if you had more complex, you could actually choose which one you would want. So obviously the available options are ham, pepperoni, meat, veggie, etc., etc. So, okay, that's pretty cool. I can create that, and that automatically created a training data set for entities. So now chatbot should be able to understand. So I can even test it, and I can say ham and pepperoni. So this is like us just testing NLP, and then you can see the chatbot understood that ham was a pizza and pepperoni was also a pizza with 100% likelihood. And I can say small pepperoni and also test that. And you can see chatbot understand that this is an entity and this is an entity. So not just some random words, which is pretty cool. Okay, so let's update our chatbot in the cognitive flow. So we had one question where we're asking for the size of the pizza. Now let's ask for what pizza people want, right? So it's going to be another step question, and I will save this as a pizza. Entity type is pizza as well. And we could say, which pizza would you like? And if I do display type quick reply, then we'll just get like those little buttons. But what I want to do is actually display it as a carousel, because we have a whole bunch of information available for our chatbot. So we could basically train it to display those. Okay, so a carousel would require few information. So we need to add button text. So it's select pizza. And it's also that we also have a title, which is select pizza. And the reason why we have one property that sounds pretty similar is that if you were to use this chatbot that is not a web interface, the fallback would be like a list picker. And in this case, the button text is what you click to open the list, and the title is of the button that you click to confirm, or the other way around. So next thing that we need is data source. So where should we get all the records? So we say endpoint, and we'll get it from demo API sample pizza. And then finally, we will have a template. So a template is basically we're saying what items should we be getting from each of the records to display the nice carousel. So we have properties like title. So that's like the name property. And I'm using this double mustache. So basically, this is like a syntax for interpolation. So that means that if I have something inside mustache, when the chatbot gets to this point, it will get from the record, it will access the name property and then replace it in here. So if our property value name was meat, then this will get replaced with meat for us in a dynamic manner, which is pretty nice. What else do we have? We had an image there, which is IMG property. And then finally subtitle. And if we look in here, yeah, let's use price as the subtitle. And I should be able to save that. And we should be able to try again. So order pizza, make it small. And now we see we have a nice carousel with all the pizzas. And I can hear all of you already getting hungry and wanting to get a pizza. Another interesting thing about me while we own pizzas and stuff, I am doing this challenge where I am not eating any meat for the full year of 2020. So I have like I basically every pizza I eat now is veggie, but I will not eat a vegan pizza because a pizza for me, a good pizza should have cheese. Unless you're lactose intolerant, you have no excuses to have vegan pizza. Sorry, I'm just kidding. Okay, so next thing that we should probably have is another question where we could, for example, ask you for address, right? So that's going to be a question where we ask for any type of text, and we could ask something like, where should we send it to? Okay, and the chat will give us a response, and maybe another question where we could ask for your email address. So that's also like a textual answer. So we could ask, what is your email address? And then finally, we could do like a confirmation type step. So what I can do is ask the user to confirm some of the entities. So we could, for example, ask the user to confirm maybe the size of the pizza that they want, and maybe confirm the pizza itself. We could let them change the email address. So it's up to us which of the properties we want to let them change. And we could say something like, can you, or let's say, are you happy with this order? Right? And that's pretty cool. So we allow the user to choose some of the entities. So let's run through this process one more time. So when order pizza, make it large. Nope, I said I'm vegetarian, so we are going for margarita. Where should we send it to? So La Casa de Sebi, Manchester. I'm in Manchester right now. And what is my email address? sebi@nativechat.com. That is not my email address, but should be fine. And you see, like, the chatbot allows us to actually change any of the information. So I could actually say, like, well, maybe I don't want margarita, and maybe, just maybe, I could go for kale ricotta, because that's veggie too. And then I can go and confirm the order. So pretty much we are able to like go through it step by step, and once we have the conversation completed, we should be putting this order through somewhere. So what we have, there is a step of type webhook that allows me to make a post or post request to a service that will allow me to send that order in this case. So I have this little API again that I have this basket for NG Poland that is empty at the moment. And if I make a call that is similar to this, I should be able to do something like that. So the API requires me to pass the name of the pizza. So I'll say handlebar pizza. And for the price, instead of hard coding 20, I can say pizza.price. I think that was the name of the, yep, that was the name of the property. That's cool. No headers required. And we can, in the payload, also send some additional information. So I can send the email address and maybe the, let's say, delivery address. So I'm going to send it here, and that's going to be, again, address in handlebar. Cool. So once that's done, and when the service gets a response, we can display a message saying your pizza should be with you in, let's say, 30 to 45 minutes. A lot of people want pizza at this time of the day. And actually, I'm going to display it in multiple lines. So let's add another line saying, please keep a safe distance. We should all be very, very responsible at the moment. So, okay, so we can go order pizza, make it large. Well, just because I don't need meat. I think Darek wants a ham pizza. So where should we send it? Darek's home in Warsaw. I'm pretty sure they will know it. Still email sebi@nc.com. Yep, I'm pretty happy with this order, and we're getting response. And finally, this should have updated our basket. Fingers crossed. Yes. So we've ordered a pizza with this price. We said it's a name pizza. We just wanted one. And this is my email confirmation address, and then the delivery address. It still should work, right? Like spelling mistakes, you know, we live in modern times, things can be picked up. So before I show you how to actually deploy this pizza, I want to show you a couple of tricks that we can do. So I mentioned things that the chatbot should be able to help us and remember some of the things that it can do. So we have this thing called reactions, and in reactions, we can have suggestions, right? So we could say, you usually, actually, no, you say, so the suggestion is basically when the chatbot remembers your previous choices and then suggest a specific choice for you, right? So do you like your pizza? And then I can say size. And then that's basically one of them. Another thing that we can do, for example, so I'll do one for each of them. So I'll add another reaction, and this reaction is gonna be for acknowledgement. So the chat will acknowledge that if I provide the name of a pizza that I want without it asking me, it should actually acknowledge it. So the child could say something like, you got it. We will send a pizza, right? So he acknowledges that if I say I want a ham pizza, he can basically say that. And we can also do another thing. So I want to do that for email, where we can validate the input. So I can say reaction, validations, and I can, let's say, do validation email. And we could say like, please give me a proper email, or no pizza. Let's put a sad face, yes. Okay, so there's quite a lot to process, but we can actually use this chatbot by providing a lot of information even up front. So I can say, I want a meat pizza, right? So the chatbot now, and look at this, I'm going to choose small pizza. At this moment is like the last option, but I will choose the small pizza. Where should we send it? So you see the chatbot one, it didn't ask me for the pizza and actually gave me this acknowledgement, which is pretty cool. And now I can say, where should I send it to? Send it to Darek in Warsaw. Okay, again, sebi@nc.com. And this is an invalid email, right? So you can see we're getting a validation message, and the chatbot asked me for the email one more time. So I can say sebi@nc.com. So that was pretty cool. Not much effort. Let's confirm that. And that pizza should be added. Okay. So I can say one more time. Oops. I'm gonna add order. Did we have Hawaiian pizza? Because we should be able to order that for Ski. Ooh, there is no Hawaiian pizza. Sorry, Ski, you're gonna get pepperoni. Okay. I am hungry for pepperoni. And this time, small is the first option, which is pretty cool. So the suggestions already start helping. So send it to Ski in Hawaii. I think that's how you spell it. And let's, oops, what happened here? We should be able add a little palm tree here. All right. What is your email address? Again, sebi@nc.com. Confirm. and the pizza gets sent. So now the final test, I want a pizza. Do you like small? Yeah. Do you like your pizza small? So this is where the suggestions started kicking in, because basically the way the process works is the first time you choose, the second time you come back, the option comes as the first, and the third time you come to a chatbot, you remember your last option. So it starts providing suggestions. I can say yes, and then we can move on, and then to Manchester. One last time. Yeah, why not? nc.com, confirm, and we should get a ton of pizzas in here, which is pretty amazing. We got lots of orders for a total almost 40, whatever currency you're using. So the final thing that I want to do, I have this demo that is based on a project from Todd Motto. So he created this little project where you can actually order pizza, see your change base, and do different things, and do all sort of filtering on that. So imagine we have a pizza delivery service that already has ability to order through the website, but they also want to add a chatbot. So how we're gonna do that is by going to publishing, and you have all sort of different options to publish this chatbot. So I will go for the website, and we have two types of configurations. One is there could be a little pop-up coming up in the bottom corner, or this you could actually inject it as part of a div. So you could have the chatbot sitting right in the middle of the screen. So I'm going to use this configuration, and I will go to my StackBlitz project. So in this case, we will add the project over here. So I'll minimize that because we don't need, well, maybe we could show a, oops. Well, okay, that, yeah, you can see that the icon appeared. So what I want to do first is there are a couple of scripts that we have to import. So we're importing a JavaScript file and CSS styling for that, for native chat. The other thing that we have is basically our chatbot configuration. And I can even add an image, sorry, avatar URL. So that will be to provide an image that will be like an icon, just like this little guy. So I will copy this URL, post it here. And basically, this is added to the index.html. So you could, if you add this code just to a specific page, then you could make it work just from one specific page, but I want it to be available on all pages in this website. So if I save this and go to our website, we should be able to reload that, and that should be working pretty soon. So we have this little icon, so I can click on it, and our pizza delivery guy pops up. Here's what I can do, and I can say, I want a large meat pizza. That should work. Nope. Okay. I want a large pizza. Let's do that. Yep. So we didn't do acknowledgement for large pizza, but now this order is for me. So where to send it? Send it to Sebi. And well, actually, no. Let's send it to the Meerkat enclosure. Cool. Meerkats at lovepizza.com. That sounds about right. That got confirmed. And the pizza will be with them in 30 to 45 minutes. So that's pretty much in a nutshell how you build a chatbot with native chat. And I hope you find it all pretty exciting. In my opinion, this is really cool, and it could bring attention even to a bunch of little mice. So just to recap where to go next. So if you liked what you saw, you could actually go to our website and check out native chat. The playground where I was developing everything is at bots.nativechat.com, and you could create a new account to start playing with native chat. There's no strings attached to get started. You could check out the documentation at docs.nativechat.com. There's a bunch of tutorials. So I created one tutorial for building a chatbot just like you saw, but it's in a lot more details, and you would build a chatbot for a car rental company. And you can also learn, there's another tutorial for building chatbots for Alexa. We also have a pretty cool case study with a hospital in Sofia that they're using the chatbot. I recommend checking it out. It's pretty cool. And if you want to play with the demo pizza project that I was just showing you a moment ago, and with the chatbot that I built, you could go to this bit.ly link. So just bit.ly or ly/Angular pizza chat. So, and it's very important, no electric sheep were hurt in the making of this presentation. So yeah, thank you for listening. And I think that's the end of my presentation.
Oh, wow, thank you so much.
Yay.
Okay, so now we have the next speaker. Thank you one more time, Sebastian. It was great to see you. It was great to hear you.
Yeah,
and
absolutely.
Have a nice evening. Have fun on the rest of this presentation. And now we have Nishu. Whoa!
Woo.
Nishu, we can hear you. Okay, now it's not.
Yes, can you hear me? All right, so I hope everybody can see my screen now.
Yes, we can.
Great. So hi, everyone. I'm very excited to see you all, and I hope all of you are staying safe. I'm going to talk about the Angular router today, and I consider it my favorite topic because mostly I've been talking about Angular router a lot, and I also have a book about Angular routing, so it kind of my favorite topics. So to start a bit about myself, my name is Nishu Goel, and I work as an engineer at IBM. I'm also a GDE, a Google Developer Expert, and a Microsoft MVP. You can read my blog around this, around the concepts of Angular on this blog post, and also check my repository for the POCs that I do on GitHub here. So the session today looks mostly like this. We're going to start off with talking about what is Angular router. We look at the life cycle of a router and how events come into picture, how guards come into picture, what are resolvers? Have we as developers come across resolvers at all? Then we look at lazy loading of routes, which is a very important and very interesting topic for us developers. And finally, we'll go on and talk about the different updates in the latest versions of Angular, mainly about the Angular version 7, version 8, and version 9. So I hope you enjoy the journey. Now, for those of you who are very new to Angular or Angular routing, I'll quickly do a basic, the introduction to what Angular router is. So to start, Angular router is actually the official library for performing navigation in your Angular applications. And if you want to navigate from like one view to another, there's a reason I'm saying view and not a page. We'll talk about that. And it comes packaged as the Angular/router library. It comes with within the Angular repository. Now, the purpose of using Angular router is that it helps us navigate to the configured route for the components which are routable. Now, there are different components in our Angular applications, right? Maybe we use them as nested components, or we use them as routable components. And for the view where we want to navigate from one view to another, that's when navigation is required. And if you try to understand this, we would have to go back a bit and think of the traditional web applications. So what we would usually have is we would have multiple pages which are linked to each other, and we'll route from one page to another page. However, with advancing technologies, with SPAs coming into picture, single page applications coming into picture, we would have one page, which would be like one placeholder, and we would have different views. Now, this obviously doesn't mean that, for example, there's an e-commerce application and you would have all the different views on just one page. But we would have different views and we would navigate from one view to another view on the same page, right? So you can consider it as a placeholder. We'll again come to how we do that. Now, there are a few steps involved when we are dealing with Angular routing in Angular applications. The first is importing the router module. We import the router module from the Angular router package. The next step is to configure the router states. Now, router states are something that would help you define that which path takes you to which view, right? Because you would have different views now instead of pages as such. And finally, you would be able to navigate from that particular view to the next view. This is what a simple scenario looks like. Now, let's go through each of these steps and try to understand it. So the first step is to import the router module. So you import routes and router module from the Angular router. And you would define that in your imports array. Let me quickly have a look. Yeah. And there's also a configuration. If you have worked with Angular 7 and above, you might know that there's CLI prompts. Now, CLI would ask you if you want to generate a special module, app routing module, right? And that's when, if you say that, would you like to add Angular routing to your application? If you say yes for that, you would have a separate module generated, which is the app routing module. And in that case, you can simply export the router module from in the exports array, and it would be available for your whole application. Now, if you're able to see something called for root here, my first question to you all would be, since I would really want to make this, this session interactive. I know it's difficult with the virtual sessions, but I'll still try my best. So the first question to all of you, I'll just put it in the live stream in the chat here. What would happen if we don't add for root in our router module configuration? What would happen if there is no for root? So Darius, if you could share it in the chat, in the live stream. So in the meantime, I'll move on and I'll wait for your answers in the live stream. Now navigating, the next part is navigating from one route to another route. So the first thing, you can either route from the template. For example, there's a button or there's a link where the click of which you want to route from one view to another. That's when you would use the router link directive and specify whichever route you want to go to. For example, currently I'm at the home route and I want to navigate to the profile of the user. So I would simply use the router link directive, which tells the router that you specifically want to move from the current page to the page that is mentioned, the view that is mentioned, I should say. And there are scenarios when you would actually want that there should be some action before you actually route to the next view. For example, you might want to toggle some flag in your application. That's when you would want to route from the code. So instead, in the template, you would simply add a click functionality, for example, on your button, and you would say that on the click of this button, there's a flag toggle that should happen, and after that, you should now navigate to the next route. That's when you would want to do it from the code, right? From your component TypeScript file. That's when you can inject your router as a service and then navigate to whatever page you want to define there. Now about the router states, which is the second step in your routing configuration. So that's when you have to define the different states, different router states you want to go to. For example, there's a connect route, and which would take you to the connect component, a profile route, which might take you to the profile component view. And what's very important here is the order of these routes. So you really need to be very specific about the order of these routes. The last configuration, that the last router state that you see here, which is the path with asterisk, and the component is called wildcard component. This is basically a wildcard route. This basically means that in all your configuration, if the router is not able to find any of the paths that you have specified, but user has entered such a path, what would it do? It would take it to the wildcard route, which can be a page not found route, or whichever error page you want to give, for example. And this needs to be in the end to make sure that all your other routes are checked before the router goes to the last route. Otherwise, even if you put this wildcard route at the first, it would always go to the wildcard component, and it will not even look for the other components. So this is a pretty important step when you're defining your routing states, router states. And the important part here, which we need to focus on, is the same that we were talking about, that we need to place the wildcard route in the end to make sure that, you know, our router compiler, I mean the router, doesn't go to the wildcard route every time. Then comes router outlet. Now, this is the very important step in your routing configuration when you're preparing for routing in your application. And router outlet is what basically acts as a placeholder in your application. So for example, you have one view wherein you want to display different components, different views. That's when you would define one view, which is your router outlet. And here you would specify the different routes that are coming in. So this basically acts as a placeholder for your whatever view you want to specify. So for example, you have a header on your home page and a footer. And in between the body, you're not sure of whichever view will come in. That's where you can specify the router outlet, which will act as the placeholder, and your routes will keep on coming in whenever you redirect or navigate to your next view. So that's what router outlet does. Mostly, if you're forgetting about, if you face some error about routing and are not able to see the view, it might probably because, you know, you might have forgotten about adding the router outlet. So that's pretty important. Now, I didn't get a chance to look at the live stream chat, but for people who are wondering why we are using for root and what happens if we don't use it. So this is basically because we want to create one instance of the router for our overall application. There needs to be one router in the application. And this creates one instance of our router module for the whole application. And this would basically mean that this particular router module is the one which is our router. And all the feature modules or your child components will have the for child directive here, for child method here of router outlet. This basically works as per the module with providers, which defines it as a provider for your whole app. And then router module becomes one instance for your whole application. And our application will break. For example, you don't use for root here, you don't specify it, your application will break because you cannot have multiple routers in one application. So this is pretty important. And now there are few demos and examples that I have in between. So if I open this one quickly, I'll also share this with you in the chat section. So in the meantime, so that you can try as well. So Darius will be sharing another link with you, which is about the order of routes. And this is a very basic application, which will talk about routing in general. And if you see here, this is our routing module. And actually, you don't need to have it as a routing module as such. You can simply export your routes from here by removing the module and exporting the routes directly. Then you can remove this module part and define your router module inside your app module.ts, which is here. So for now, I'll simply remove the export thing that we mentioned. Yeah. Now this is what our routing configuration looks like. We have a hello component, we have a main page component, and then we have a first we have a redirect component, and then finally the wildcard component. Now, if we want to play around with the order of our routing states, I'll simply cut it from here and paste it in the first place. So this is the first route for us now. And if you look at it, let's open it here only. So I actually have a main page component. If you see, this should take me to the main page component, but it looks like this route is not available because it says no such route available. And this is because the router cannot find the main page route. It is not even going to that. It ends right here because for every particular path, it will just throw the page not found component because it will not even go further, which is why the route configuration, the routing states become very important, and the order becomes very important. So now it should be fine. So if you look at it now, the router is able to find the main page because there is this order of configuration that matters. So yeah, this is all about this particular example. Moving on. Yeah, so we have seen the order. This is fine. Wildcard route, we know that what wildcard route is. You can specify it as a page not found component or whichever component you want to specify. And the next thing then that we come across is the location strategy. So many of you might have faced this problem that when you deploy your application to production, you're not able to find any of the routes because the browser would just load index.html and then it will just not recognize the different routes. That's when location strategy comes into picture. And there are two ways to handle this. Either there are different types of location strategies. What we basically by default use is the path location strategy, and then you can go for hash location strategy. And if you want to deploy to production, you would usually go for the hash based one, so that it makes sure that all the routes are rendered with your index.html. And when you're trying to go to any of the routes, it is recognized. And if you look at this example.com/hash/foo, this would take you to, this would be a hash based location strategy. And the other way of doing it, if you don't want a hash in your URL at all, you can then specify it on the server and make sure that your index.html actually carries all the different routes. So that's about how location strategy takes care of routing and the browser URL. Coming to the next part, which is about the router lifecycle. Now, this is quite important. If we understand all the basic things about routing, we'll be able to understand what router lifecycle does. So this picture basically sums up what the lifecycle of a router is. We first check for the URL. We redirect to the URL if it is there if there's a redirect URL in our application. For example, in the demo, you just saw that in the routing states, you would mention an empty path and redirect to the component whichever you want to go to. For example, you're just going to localhost 4200, but then if you have a redirect route, it would always take you to, for example, localhost 4200/home, right? That would be your redirect. So the first thing that the router checks is if there are any redirects present in your routing states. When that redirection happens, then it would specify the URL in the browser as per the router path. So if the router path said /home, redirect to /home, it would update the URL in the browser. When that happens, the next thing it does is to check for, it should now be able to navigate basically, right? Because it has it in the URL and it is ready to go to the next view. However, what comes in between is the guards and resolvers. What is that? We'll come to that. But in between, if you just want to quickly understand, so guards will basically put a check on your routing, on your navigation, that are you allowed to do that? Are you maybe authenticated to do that? And resolver is also a type of guard, but we'll talk more about that. Once it is done with checking all the guards and resolvers, the next step the router does is finally activate the view. And where would it activate the view? It would happen exactly where your router outlet is placed. That's why it's called the placeholder for your routing, right? And the same procedure repeats again. It would check for the redirected path. It would update it in the URL of the browser. It would check for guards and resolvers, finally activate the view. So let's look at these one by one. So first off, a very interesting thing that you can do to observe the life cycle of the router is to use first of all, use router as a dependency in your component and subscribe to the events, whatever are there that the router is subscribing, that the router has in the configuration, in the states. And that would come through the router event. You can maybe log those events to the console to see what are the different events happening at which step in the life cycle of the router. This becomes very interesting because this helps you to know what exactly is happening at what time. So if you want to use it for debugging purposes, that at what specific moment, what exactly is happening in your router lifecycle, you can just go to your router module.forRoot method and use enable tracing as true. This would really help you to debug what exactly is going on with the lifecycle of your router. And moving on, so this is what it basically looks like. I have a demo for it, but since the font will be very small, I've placed it here as well. And I think first we'll go for the demo. So this demo will basically talk us through how different events are used in the router lifecycle. This would be about router events. If we could go to the hello component, you can see that in the hello component, I've specified the router dependency here, and you're subscribing to the different events that our router is subscribing to and what is there in the life cycle. So if I quickly open the console, you can see the different router events. Now, I know the font might be very small, but just to get started, the first event that gets called is the navigation start event. Now, this is very important to see because when your navigation starts, it's just started, but it's not updated in the browser URL, and also it's not navigated to whatever view you want to go to. So now in the presentation, in the slides, if we want to have a better view at the different events, first is a navigation start event. This takes care of whatever URL you are sending. If the navigation has been triggered, the next step that it will go for is to see that if routes are recognized. Now, the routes recognized event basically makes sure that if that particular URL exists in the router states that you have defined in your routing configuration. For example, the user goes to the URL called maybe /random route, and it does not exist in your routing configuration. Then this next event, routes recognized, will basically throw false that this particular route is not recognized. What would happen then? Either it would go to the wildcard route that you have defined, or if you've not defined, for example, any route, wildcard route, then it would throw some error, right? So that's what comes in the second part, which is the routes recognized event. When that check is done and it has recognized the route, it would update it in the URL as we discussed, which is the second step of our router lifecycle. It will update it in the browser URL, but it should be allowed to navigate now, right? So if we move on, we'll check this. Now we should be able to navigate, but there's some problem. What is that? It needs to check for guards. Now, guards are basically a check on our routes, whether we are able to, route to a particular view or not. Now, to understand this better, let's take the example of Amazon Prime, right? So it is primevideo.com, but let's imagine that it is called, it's something like amazon.com/prime. And when you're trying to go to the /prime route, the Amazon is not sure if you're actually a Prime user, right? And that's when it wants to check that if you are a Prime user, then only you should be able to navigate to that particular view. Otherwise, you should not even see the /prime view, right? And that's where the authentication of you being a Prime user or not happens. That's what the guard will take care of. The guard will do that validation, will do that authentication. If you are, it will navigate to the particular view. Otherwise, it will throw you, maybe on some other route, or it will just, give you some error. So let's have a look at what are the events that are used in the process. So the router makes sure that it would first run the event guards check start, because the guard checking has started now. It will look at the URL. It will look at the various logic related to maybe authentication that you have given. Once that is done, it will start the child activation. If there are any child components defined, it will make sure that the activation of those child route happens. Then the final activation of your route will start. In the process, if your guards check has ended and it has given you true as the value that it has given you false that there's no problem with the guard, it's null and you can proceed, that's when you would have to proceed. However, if the guard fails, the router emits the navigation cancel event. This would basically mean that the navigation has cancelled, and then it depends on you that what action you basically want to take as a developer when the guard has failed. And if you want to look at, have a look at some of the guards that are there, these are can deactivate, can load, can activate child, can activate, and resolve. Now, I've written these in the order of execution of these guards, which is important because it happens, there's a flow that it follows. The first thing that the guard the first guard that would implement is basically about if you want to navigate away from some view. That's the first step in the process. So for example, I'm trying to go from the home view to the profile view. The first step in the process would be navigating away from the home view. Let's think about the profile view a bit later. We are navigating away from the home view. That's the first thing. So the router would want to check if you're allowed to navigate away from this view. For example, you might have some unsaved information on the home view, and you would want to check, you would want the router to check as a developer, you would want the router to check that that the user should not be able to navigate away if he is not maybe saved the information. That's something that your can deactivate guard can help you with. Once that is done, the next guard that executes is can load. We'll ignore this particular guard for now because this is involved with lazy loading in our routes in our Angular applications. So let's keep that aside for a moment. The third guard that gets activated is can activate child. So it would check if the child component particularly can be navigated to. If yes, then the can activate. That's the fourth execution. The fourth step in the execution of your guards. So it would finally check if your particular route can be activated. If it says true, that means okay, there's some authentication that has happened. If it says null, that basically means that okay, the guard succeeds and you can go forward. If it says false, for example, then there's the navigation cancel event has been emitted and you need to take some action there. Finally, the resolve guard is called. Resolve is actually also a guard. However, we use it for saving the partial loading of our pages. We'll talk more about this a bit later. Now, to look at one example of a guard, this is the can activate guard function, which is the most used guard out of all of the guards. Now, this would take the activated route snapshot because it needs to know which route you're currently on, and it basically would send different types of values, like a promise of a boolean or a URL tree. We'll talk more about what a URL tree is. And then it depends totally on what configuration you have given. For example, there's some permissions that the current user needs to follow, and of this particular ID, for example. And when that is done, that's when your guard will execute and generate the particular URL, the next URL that you want to go to. Not generate, but then activate it. When that is done, the next thing that you need to check is if you want to create a guard, you can simply create it using the CLI, using ng generate guard and the guard name. Now, this works exactly like a service. It would have an injectable decorator, but it is a guard. And it always runs before fetching the data because you want to make sure that load the data only if the guard succeeds, if you are allowed to navigate to the particular view and load the data. Now, talking about route resolvers, so let's imagine a situation first without the route resolvers. So you click on a particular, for example, a button, and you want to go to a component. Now, you might have observed this, that first what you see is a partially loaded view. There might be some static data that comes on the screen, on the view, and that's when you wait for some more time because you know that there's some asynchronous call that's happening and you're waiting for that data from the server. Once that comes, that's when you get to see the fully loaded view, right? Now, this is not a very user-friendly scenario, and that's when you think of something that would help you get all of the view together so that you don't face this partial loading of data. And that's what resolvers help you with. So you can actually pre-fetch the component data during routing and then show the view only when all of the data is available. Now, the router events that are emitted for that are resolve start and resolve end. So resolve start will basically make sure that now you start resolving the data because I might go to the route in some time when I would need the fully loaded view, right? And this is the scenario which is with route resolvers. So if you have route resolvers in your application, you would click on the view on the particular, for example, a button or a div from where you want to navigate. Now it would call the resolver service, which makes sure that all the data is gotten from the server already. Once you get all the data, that's when you would load the full component. Now, again, That would again lead to, some wait time. And this again, you might wonder that why to, wait for whole data, even the static data is not coming in, and there's a delay, there's a lag in the process. You might not think it very friendly. And that's why in most of the e-commerce applications we use something like spinners or loaders, right? Loader components. So that's how we usually handle such scenarios. Now, when resolving also is done in your life cycle, the final part that the life cycle of router does is the activation of your route. So these are the different activation events that the router emits, which are activation start. It would then end the activation. Child activation also has to start, and then the ending of the child activation. When that is done, when your router is activated, that's when your router needs to tell the browser, communicate with the URL in the browser and update the particular URL, right? And to do that, this is the method that gets called update target URL and href. Now, this uses the location strategy to prepare the URL, whatever URL you want to specify in the browser. And that's when you would give a string property of whatever URL that you are sending to your browser. That's about resolving and activating your view. Moving to lazy loading. Now, if you see this image here, this is from one of my colleagues, which I found very interesting, and I decided to use it here. So yeah, lazy loading is mainly about loading a feature module if you don't want to load it already, because you might not need it at the moment and you're not too sure if it will be needed at all in the application. And again, I think I'll go back to the Amazon example that we were talking about and try to explain this better with that example. So let's imagine that there's amazon.com/prime. Now, Amazon does not want to load the prime module of the application if it's not sure if the user is even a prime user or not, right? So since it's going to be a big module, and Amazon really wants to make sure that let's not even load the module if the user is not a prime user. That's when it would want to make sure that load the prime module only when it is checked, it is authenticated that the user is a prime user. That's when it would try to do lazy loading of that particular module. With the main module, it would not load all of it. It would load it only when your requirement comes in, right? And if you try to understand it through this diagram that you see on the screen, the browser would be sending the request to the server, which sends back your index.html. And that's when you might get to know that, okay, there are some extra files which are needed. Then those lazy loaded files come into the picture. That's when, for example, here you get to know that, okay, the prime user is it's a prime user who's using the site currently, and you might need these lazy loaded files. That's when another bundle comes into the picture, and you load that bundle and make those files available. That's when lazy loading of routes come into picture. And to perform the lazy loading, that's how you do it. So you would specify the path, and you would want to load the particular module. For example, in this case, the user module. You would simply import that. And before Angular 8, this was not how the syntax used to be. It was just a string of whatever module you want to load for your lazy loading strategy. However, after Angular 8, starting Angular 8, you would actually have a dynamic import of your lazy loading routes of your modules. And that's when can load guard comes into picture also. So if you want to specify that if the user is authenticated to load a particular module, then only load that. Otherwise, don't even ask the application to load a particular module. For example, you're trying to load the prime module without even checking if without even getting authenticated that you're actually allowed to authenticate and load the particular module. That's what can load guard would help you do that. So it would load a particular module only if you're allowed to load it, if the user is allowed to load the module, and the criteria will be checked before that. Now, again, to make sure that the process doesn't get very lagging, or it shows some delays in the process, that's when preloading strategies come into picture. Now, there are different types of preloading strategies. Like if you might not want to preload any modules. Preload basically means that you want to make sure that you are sure that this particular module is going to be required at some point, but you don't want to load it with the main bundle. Now you would want to load it in the background when the application is running, even if the requirement has not yet come in. So for example, you want to load the Prime module in the background when the user is browsing through Amazon, or might just check his cart or something. That's when you would want to do some preloading, and that's when preloading strategies would come into picture. Now there are different ways to do that. You might want to prefer to preload no modules. You will not prefer to load any modules eagerly before it's actually required. Or you would want to preload all the modules because you are very sure that the user will come across those particular modules at some point in the application. So you would also load all the modules in the background. Then there will be something like custom preloading strategies. In that case, you would specify that load this particular module for me because this is important, but then not this one, and load it only if the user needs it. So you can read more about preloading strategies here. I'll be sharing these slides with you so you can pick it up from here. And this is something important when you talk about importing, using the dynamic import of your lazy loaded routes. So the load children property that you see here. So earlier, when in the string syntax, you could actually use destructuring. However, with the new code which allows dynamic import of your routes, that's when forced typings are not taken care of. And if you try to use something other than these, you might get to see some error like this, which says that only import string m and export name can be replaced in this format, because the current code doesn't account for forced typing in the destructuring format. So you would be able to use either import string or m and export name. So that's something that needs to be taken care of when you're dealing with dynamic imports. Then if you want to have a look at the bundle size difference. Now this is a very small application from which I've taken an example, but you'll see the significant change when you're dealing with bigger applications. Now this is one application where there is no lazy loading at all. And if you look at the main bundle, it is 151 KBs. However, if you implement lazy loading, you might see the main bundle, which is 142 KBs, but then there's this other bundle that's generated. In this particular case, it's called publish module, which is of your publish module, which might be a feature module in your case, which is just 9.4 KBs. Now, again, as I said, this is a very small application, so you don't see a significant difference here. However, in bigger applications, you might get to see, and it will really bring down the size of your the main bundle. And this is a very interesting demo that you might want to play around with. So let me quickly share it with you. So in the routing configuration, this is a simple routing module which takes care of your hello, which has your hello component. And if you look here, you can see that for this particular path, which is your hello path, you're trying to load a module, which is the hello module. And this hello module basically contains your hello component, which will be loaded and which would show in the console only if you go to that particular view. So let me quickly open it in a new window. And let me just clear this up. Now, if you look at the application, we would get to see that, where is the module? Yeah, so it basically shows that if you want to go to this particular route, which is the hello route, it would go to this, it would load this particular module. So you can simply go to the hello route here and check in the network tab what really happens. So if you see here, your hello module gets downloaded, gets loaded only if you go to that particular route, right? So you can try and play around with this one. This would be about lazy loading mainly. Moving on. So yeah, when we have discussed about lazy loading, this would be the time for discussing the updates in the router. We'll mainly talk about the different updates that came in version 7, version 8, and version 9. And the small link that you see at the bottom of the slide is a URL of the blog post that talks in detail about all these updates. So you can refer to that as well. So in the version 7, or maybe let's start with version 9 first. In version 9, there was just a very basic change with the router, which was about the router link active directive. So this earlier would not work with the arrays if we specify those in the query params. So any query param which would not contain any arrays, it would totally work fine with that. However, if it would contain array, it would not. So there was a small bit of change in the code, which would now allow arrays as well in the query params when you're defining your router link active directive. Then if you talk about version 8, the dynamic import of lazy loading of routes, we have already discussed that. So earlier there was a string that we would usually use to lazy load our routes, just like in this example. However, now we would dynamically import that module when we want to lazy load a particular module on the requirement on when you go to a particular route. The other thing was hash-based navigation. This was more related to upgrading when you're upgrading your Angular application. So you would have one more property called hash-based navigation, wherein you can specify the path that you want to give. This was not before Angular 8, version 8. In version 7, there were a few interesting things that came in. So let's discuss the second point first, return URL tree from the guard. So before Angular 7, the guard would usually either return true or false. However, with version 7 coming in, the guard would actually return a URL tree. This would be about, so if the guard fails, for example, it emits the navigation cancel event, and that's when you need to specify that now which route to go to if the current route has failed. That's when you can specify that particular URL, parse that URL, and send it from the guard. This would make sure that if your guard fails, this is the next guard to go to. And that's when another problem comes in, which is about multiple guards coming into picture, because there was a guard already running which was taking care of the current navigation, but now this guard sends another URL to be navigated to. That's when guard priority comes into picture. And there's a property that you can use for that, which is called prioritized guard value, where you can specify the priority of the different guards. And that would take care of which will be running first and which guard will be running after that. That's about the guard priority. Another thing is the first example that you see, the first point that you see here, which is about add path params change mode for run guards and run resolvers. Now, this method basically makes sure that when should your guards and resolvers run? Should they run always whenever there's a change in the URL or in the query param or in the matrix params, or should it change only for a particular condition? So there was one more option that was added here, which was path params change, which would make sure that it actually runs the guards and resolvers only for a change in the path params, which can be query params. So that was about path params change. So you can read in detail about this at this particular blog. It's the Angular router in the latest versions. And these are some of the resources that I followed for this routing presentation, which is the Angular change log, Angular documentation. There's a very interesting Angular router series by Nate Lipinski on Angular in depth. You can check that out. And then I've written this book, Step-by-Step Angular Routing. So you can also refer to this one if you want to dive deeper into what Angular router does. This would talk about child routing, secondary routing, route resolvers in detail. It also has a GitHub repository attached to it. So if you want to look at any of the code examples, you can simply go to that GitHub repository. And that repository actually would be just Angular routing book if you go to my GitHub. So yeah, that's all. And I would thank you a lot for joining my talk today. And you can connect with me on Twitter or GitHub or read my blogs around on concepts of Angular on this particular blog post. So thank you, everyone.
Thank you so much, Nishu. It was a great presentation with a lot of valuable information. So one more time, thank you so much. And now Lars, the stage is yours. So have fun. Thank you, Mish, so much.
Thank you, Darek. Let me share my screen. Is it shared now? Okay. I hope that it's shared now, or give me some sign, Darek, and I'll figure it out. I have too many screens on my setup here. Okay, so I'm Lars Brink. I work as a front-end architect for System8 in Denmark, and we use Rockstar developers and continuous delivery to build better software faster. I also write a lot for indepth.dev, so you can find a lot of good material in there, and some of it is mine. And today I'm going to share with you Ivy's best kept secret. So sure, there's a lot of new exciting stuff in Ivy. And you know, even a year ago, I was asking, you know, Ivy is nice and all, but where are my shiny new features? It took a while, but I went digging in the source code and I found it. And that's what I'm going to discuss with you today. So, sorry, that's the wrong slide. So features, it's called Ivy features. And you would think that a company built around a search engine would come up with a better name that you can actually search for on Google search, for example. And before, like half a year ago, you couldn't find anything relevant if you search for Ivy features, but I fixed it for you, Google. Here it is in the top 3, depending on the country you're searching from. Search for Ivy features, find my article on in-depth component features with Angle Ivy, and you can get some of these details in writing instead. So what are the features? Well, they are the Angular way of doing mix-ins. So it's a way of doing composition rather than inheritance. So we can mix in different reusable pieces of business logic or very specific ones and mix them in a declarative way. And I have a slideshow gone wild here. Apparently it remembers the last time I did it. And sorry, I will have to I will have to go back and forth if it continues without me wanting it to do that. Sorry for that. Okay, Ivy features, there are 3 types. There are directive features, component features, and host features for Bootstrap components. So let's look at some of them. This is the structure of an Ivy feature. It's a function that returns a function, and that returned function actually takes in this thing called a component definition as a parameter. We can use that to wrap the component factory and do some modifications. And in the end of that new wrapped component factory, return the component instance. And let's look at a simple example here. So we want the username state from our NGRX store. So we use this with username feature to inject the store. And the directive inject function here actually has access to the same component specific injectors, even the node injector. So it can get every dependency in the same way the component itself would, and it's dynamic. So based on every single component instance. So yeah, this is just, it's not really important. And this is the last time you're going to see the dirty insights of a component feature. Instead, we will be discussing how the use cases for it. And I think that's a lot more interesting. If you want the details, I'll share a GitHub repo with you and you can go look at a few examples. This is how we would apply it. For the component decorator, there would be a features option. We would put in, it's an array. We could put in the with username feature. And in the component class we see here, it has username $property, and it's handed and observable by the feature. So no nasty glue code to hook it up to the NGRX store. Actually, it doesn't even care where the data comes from. So I think this is pretty nice. So the only caveat here is there is no features option in component. Thank you, Angular team. No, they have been busy with a lot of Ivy things, but I hope they can expose this to us at some point. And until then, I'll share one more secret with you in a minute. So the features are actually available in the Ivy runtime, but they are not part of this decorator yet, the component decorator. So there is no option to add the features. But if we could, this is the compiled version of a component. There's this small theta CMP for component, and then define components that puts in the metadata in this static property on top of our my component class. And if we could just somehow put in our feature there, so after compile time, oh, this slide is living on its own, sorry. So I will never use that feature again in PowerPoint. I'm so sorry. So I will have to speak faster or something, I don't know. Okay, so if we could actually add these options ourselves, this metadata at runtime, but before bootstrapping the component. So it should be between bootstrapping the component and compile time. So how could we do that? Well, we could do a decorator, a custom decorator here. It's very simple. It has this little promise hack, a micro task to kind of hit that magic moment and then assign the feature to the metadata. And then we see in the bottom highlighted for each loop here that we take each feature and we hand it the component definition. And that was the structure of a component feature that we saw before. So I will move on to the next slide before PowerPoint beats me to it. So with this custom decorator, we can say add component features, give it an array, pass in our own features, and this will actually work because it's supported by the, damn it, PowerPoint. It's supported by the I don't know how to disable that. Sorry. Damn, this is throwing me off my game. I will be sending a very big complaint to Microsoft. Good that I know some people. Okay, so for the rest of the presentation, every time you see the features option being used in component, just know that that doesn't work right now, but you can use this decorator instead. Okay, so we are actually starting to see Angular somehow exposing these features. For example, here, if we use the theta render component function, we pass it a component, and it has an options object with the host features property, and Angular exposes this theta lifecycle hooks feature. What that does is, if we add this feature, we can get lifecycle hooks in Bootstrap components, so ng on init, ng on destroy. Normally, we wouldn't have that when using render component, but we can add this feature. So it's like, it's almost there, but it is not. But of course, we can use it if we're okay with, like, yeah, it's unstable. It might not get public. I hope it will. But that's just this part of it, the render components, the lifecycle hooks feature. Our own features, we can mix that in, no problem. And now it switched the slide again. So there are also these other 4 features that Ivy uses at runtime internally. It adds it to our components, our directives, based on the structure of them. So if we have component providers, it'll add this providers feature, and ng on changes hook as well if we had that, and so on. So let's take a case study here. You remember before we pulled out a piece of state from the indirect store. Let's do the same thing here. Or let's actually look at a component that's already implemented. PowerPoint, you're killing me. So we have here a to-do list component, and it injects the indirect store, and it selects a piece of state. And sorry, Alex, for using store that pipe. It's in the documentation. I'm an indirect noob. I can't help it. Sorry. So, oh my God, it'll change in a minute. I'm still worried about this. Okay, so I will just go back and forth one time, sorry. So to me, this has a few code smells that I want to get rid of. The UI, so what we really want to be a presentation component, that's what components should be about. It depends on the state container, in this example, the indirect store. I really don't want those dependencies in a component that's just supposed to render something, present it to the user. It also has the querying details of how to pull that state out of that state container. And instead of dealing with simple arrays and data structures, it's dealing with observables and unpacking them. And sure, you can just use async pipe, but it brings in a lot of other pain points that we can avoid if we want to. And I'll try to do that here using features. So first, we add this feature, and how it's implemented doesn't really matter. You can probably, as long as you understand what it does, it's okay for this purpose. So we add a feature called from store, and we say the to-do dollars property, we want to select the to-dos slice of our state or our store. And we get that injected in the to-dos property, similar to how we got with the username in the first one we saw. So that takes care of kind of the first one here. So now the component doesn't have to inject the nginx store. The feature does that, but it's abstracted away from us from the component's point of view. There's still a few code smells here, and let's see if we can get rid of that as well. So we still have the querying details, like, okay, so it's a string, but it could have been a selector or something like that instead. I just didn't care to implement the whole nginx API for this demo. So we really don't want that as well. I mean, what's the purpose of not having if it was a backend application, if I didn't have a SQL connection, but I had SQL queries in my UI, I really wouldn't want that. Thank you, PowerPoint. I'm speaking too slow, apparently. Okay, so to get rid of that querying detail, we could do another feature called to-dos from store. Of course, it becomes very specific at this point, but we got rid of the selector instead. Now we're just saying, hand me over that data in the to-dos dollar property, and I don't care how you get it. I want the to-dos. Thank you very much. So now there's only one left, and that is we are still dealing with an observable. And of course, this is just a subjective opinion, and it's not that features, you have to do this with features. No, it's my custom feature. I want to work with simple data structures and arrays rather than observables. So how could you do that? Well, let's start first with a presentational component for just the to-do item, the presentation part of this. So yeah, it's a very simple one, but I had to fit in one slide, so that's why. But so we see here in this component, it takes the input property of a to-do data structure, nothing else really, nothing about observables. And I like working in this way. It's very simple. Not a lot of things can go wrong. So let's pass that data to that IV to-do item component. We do that in the loop. We still, or we pass the to-do data structure, which we get because we use the async pipe here. But now we have this other component, which is still aware of observables. I would really like us to get rid of that. So I will create an even more specific feature here with to-dos, which will pass me the to-dos array, and the input property here would figure out that new data has arrived. Thank you very much. Run the change detection. So we could even combine it with unpush change detection strategy. So now in this, even in this, damn, it's just not my day. Okay, so now even here, I think I wanted to say that now the to-dos type here is just an array of to-dos. So we don't even have to care about observables. So maybe that's what we want, at least for this example. Okay, so we got presentation of data using features. We got rid of all the nasty glue code and dependencies and all that good stuff. Got abstracted away, so we don't even have to care about that. So now let's do it the other way around. Let's do the data flow that starts at the user interaction and dispatches an action to the store. So we have this component here. It's not a presentational component, it's a mixed component. It has both presentation and user behavior and has dependency, and it knows way too much about nginx for a component. So that's what we see here in the code smells. It's like before we inject the nginx store, the UI, the presentational layer is knows about creating actions. It even knows about dispatching actions. And I mean, if you're fine with that, that's okay. For the purpose of this demonstration, I would like to see if we could abstract that away using features. Okay, so let's do a presentational component instead. Same template as before, but instead of reaching out to the NGRX store and creating action and all that, it's simply output that string in the add output property, which is an event emitter. Okay, so we need something to catch that and connect it to the NGRX store. So now we have a to-do form container component. And you know what? So we have the presentational component, which doesn't have dependencies on NGRX store and so on. So that's the kind of user pattern. And I use this a lot with containers components, presentational components. But really, that's only because there's not a lot of other good ways to do it in Angular at this point. So maybe features can help us. I mean, it's not that I like adding additional DOM elements, because components are very tied to the DOM in Angular, as opposed to React, where you can have logical components. Stop that PowerPoint. Okay, so let's see what we can do about this. Can we get rid of these? It knows too much about NGRX, this container components. So let's see what we can do about this. Because it really exists only to do this mapping of every time the add to do event from that presentational component gets emitted, we convert it to an add to do action, dispatch it to the store. Why does this has nothing to do with the DOM? Why does it have to live here? Okay, so we create a to store feature. Again, the implementation details doesn't matter. I have a GitHub repo with it if you would like to see how, but for now, just let's look at how we can solve the problems I proposed. So now we're left with only the presentational component. We don't have to have that container component anymore. We just add this feature to store, and we say, every time the add property emits an event, pass it to the add to do action creator. And of course, dispatch it, but that's like the implementation details of the to store feature. Okay, we got rid of some of the problems, but now we're left with this presentational component still knows about action creators and stuff. Oh my God, PowerPoint. It still knows about action creators, which is an NGRX thingy, and I don't want that in my presentational layer. So let's create a more specific feature to add to do action. So we pass the option of add, so it subscribes to the add output property, converts it into the add to do action, and dispatches it to the store. So now we have a presentational component that only emits events through an output property. That's the way it was intended to be, like, at least in my opinion. And you know, I'm opinionated, so that's what you get for watching me. Okay, let's look at conclusion. There's actually a fair share of material here. And then finally, we could look if there's any questions after that, but it'll take a few minutes left. Okay, so when I was preparing this presentation, I started out like, I know they can do awesome things, but what, like, concrete things, what examples? We just saw a few here. That's kind of the second bullet, that we can actually use them to replace most of the container components. And I like container components, but only because they are the only Angular-ish way of abstracting these things, doing the separation of concerns. So I would actually like to get rid of container components, but I don't want NGRX store in my presentational components. So as we saw, we can use it to that. And the first bullet here, we see that we could also add features to pull data and parameters and query parameters out of the activated route service, and instead of having to inject that and deal with all that subscription stuff. And yeah, we could, features would be a lot nicer here. So we could just declare the data we wanted. And because the features actually have access to the same injector as each component instance, it could actually inject this activated route, which is created per component instance. So that wasn't really possible before. At least you would have to provide that your wrapping service in each component you used it. So I think features would be a better option. We could even do it to use it to manage local UI state. That's not something I have experimented with yet, but maybe if you want to, you can contact me and we could do it together. Observable lifecycle events, that's also an option with features. Convert observables to event emitters if we're being very purist and we don't want to expose subjects or observables as output properties. We only want the official event emitters from Angular. We can use free features to map them, convert observables into event emitters. So an advanced use case is, this is where you would need to go into the dirty details and work with Ivy instructions, which is, I mean, if you do need to do advanced stuff, you could do this. You could probably create observable UI events that way, with click events, key press, and so on, convert it into Ivy instructions, put it in the template function of the component. You would need to know a whole lot about Ivy instructions, but it's doable. Okay, we could even use features to manage subscriptions and call these new change detection management functions from Ivy, mark dirty, and detect changes, so that we don't have to worry about those low-level details. So this is a good bunch of good use cases for features. So I really hope that the Angular team will expose it to us. I mean, they have their concerns about exposing internals, about Angular, but I mean, all I really want is to be able to wrap the component factory with my own component factory and have access to this component level injector that can enable most of these use cases except for the UI event one. So for most that would be fine. And if you need to do advanced stuff like observable UI events, well, you wouldn't, or you would have to get into the dirty details of Ivy instructions anyway. So I think that would be a good compromise. Are you listening, Angular team? Okay, so we can use Ivy component features to create higher order components, and as opposed to other attempts at this, we don't have to use inheritance, we don't have to use custom decorators, which sucks because they are non-standard. The proposal has been abandoned. There's a new one, but it has different syntax and semantics. So even if that makes it into the standard, you would have to change all your code using decorators. Thank you very much. I don't think so. So we don't need to add extra packages either to use this. This is the official Angular way of doing mixins, but they want to keep it to themselves. So let's put some pressure on them so we can get access to these nice Ivy features. We also don't have to use a custom Webpack configuration. I mean, I love that we can do it, but if Angular CLI can do the heavy lifting for me, I'll happily let it do it. Component features, they are also tree shakeable, so you don't pay for what you don't use. So that's another amazing trade of features. So of course, with great powers comes great responsibility or huge limitations. I don't think they are too bad. I mean, the worst one is it's not in the public API of Angular yet. It's not in the component decorator or the directive decorator. You have to do this little innocent hack of using a custom decorator, unfortunately. But if we add them at just the right moment, these features, Angular will happily accept them and use them, and you're golden. But there are a few other limitations that I have discovered. We can't vary the declarations list of features. So this array of features, we can't vary it at runtime because it needs to be stable before bootstrapping. So what could we do about this? We could have higher order features that managed other features depending on conditions, because the features and their component factors, they are evaluated at runtime because they are evaluated when the component is instantiated. So of course, we can do some logic in there. So that would be a nice experiment that I have yet to do, but I think we could do it. There's only one feature declaration list per component, meaning, or directive, meaning, so if we have a presentation component and we want to supply it with this piece of state, but how could we supply it with another piece of state in another part of our application? Well, unfortunately, I think we would have to use inheritance simply for the purpose of adding different features, but everything else should remain the same. So I think that would be an okay trade-off. So join me in experimenting with features. I think there are so many nice use cases that, yeah, it's the next big thing. It's the best kept secret of Ivy out there. If you're interested in any of this nice stuff, follow some of these links, slides, the article on in-depth, and the repo is here as well. So thank you very much. Let's look at the chat here. I don't see any questions, but maybe you can do some last minute ones now if you have been holding on to a thought. So what do you think, Darius?
Okay, it's no questions, or maybe one.
Builders for the win, Santosh. Yeah. You love builders, I love features. That's the way it is.
Thank you so much for
Thank you,
this
Darek, for having me.
great presentation. It's honor to have you here. So it was a lot of great information. So thank you one more time. And yeah, thank you all for being with us in this beautiful evening. So we see in 2 weeks, I think, with next Angular Online event. So one more time, thank you so much and see you soon.
Bye.